Hello and welcome. This is lecture 11 of the Asian Development Bank 3IE video lecture series. In today's lecture, we are going to look at a study that assesses the impact of farmer field schools in East Africa. Let's dive right into the subject. Now, as you can see from the green line in this graph, agricultural productivity is low in sub-Saharan Africa. And this is despite the fact that productivity enhancing techniques and inputs are available. Now, if these inputs are available, why is it that they don't find wide application in sub-Saharan Africa? One reason could be that farmers are risk-averse and they don't want to experiment with new technologies or new inputs, which could basically put their existence at risk. They could also be lacking complementary assets, or basically they could just not be aware of these inputs and these methods. Now, if awareness is the problem, how do we make sure that agricultural knowledge is brought to the farmers such that they can use these new innovations? The Food and Agriculture Organization implemented a farmer field schools project in East Africa that I'm going to use as a specific example in this lecture. This project was conducted in Uganda, Tanzania, and Kenya, and it was assessed by Davis and co-authors during the period of 2005 until 2008. To give you some background, farmer field schools, similarly to standard extension services, provide agricultural knowledge to smallholder farmers. But they do so using a participatory approach, combining adult learning and experiential learning. The farmers are put in a position where they assess problems and find solutions to these problems themselves. The trainers serve merely as a facilitator. Now, generally, these projects go through different phases, starting with the inception phase, where the curriculum is designed and the trainers are trained. In the next stage, the farmer groups are set up, and then the training starts. The training usually goes over 1 year, over the period of 1 year, and in weekly sessions, the farmers are supported in each step of the agricultural cycle. Finally, in the dissemination phase, it is hoped that knowledge trickles from participant farmers to non-participant farmers. Now, the FAO didn't implement this project in a randomized way. And it is for this reason that Davis and co-authors had to come up with a non-experimental way of identifying the impact. The FAO particularly selected villages that were most needful in terms of agricultural knowledge and access to agricultural inputs. So the study authors had to find comparison villages that are similar in terms of topography, rainfall pattern, and most importantly, access to agricultural knowledge. Once they had identified this group of villages, they conducted a random survey in the treatment and in the comparison villages. Now, from this survey, we can identify the average farmer in the comparison villages. But obviously, when we compare the average farmer in the comparison villages to the self-selected farmer in the treatment villages, we are not comparing like with like. It is here where propensity score matching comes in handy. Now, from the random survey, we observe information such as gender, age, household size, education, land size, distance to the next market, and other variables that could be important for the decision to participate in a farmer field school. All these variables are observed at baseline. From these, we estimate an index that gives us the probability of a farmer to participate in a farmer field schools. We estimate this propensity score using pro-bit estimation. In our request to compare like with like, we have to do one more step, and that is concerned with the common support. This is technical jargon, and it means basically that we have to make sure that in the treatment group, there's no farmer that has a propensity score which is not represented in the control group. Now, this graph shows the distribution of propensity scores in the treatment group, that's the red bars, and in the comparison group, that's the blue bars. The green bars are farmers that are off the support, meaning they have a propensity score that is higher than any propensity score in the comparison group. These are deleted from the sample and not included in our estimations. Now, based on observables, the propensity score gives us some confidence that we are comparing like with like. But what about unobservables? So on paper, meaning based on observable characteristics, comparison and treatment farmers could look very much alike, like these two guys. But what if there are unobservable characteristics, like for example the green thumb, which means that a farmer has a particular touch with plants? If these unobservable characteristics are constant over time, then we can simply difference them away. For this, we just take the outcome at end line for the treatment farmers, subtract their baseline value, and we obtain the first difference. We do the same thing for the comparison group, end line outcome minus baseline outcome, and we get the second difference. Now, we just have to take the difference in the difference, and we obtain the impact. Now this gives us some confidence that we are not only comparing like with like on the basis of observable characteristics, but also on the basis of time constant unobservable characteristics. The data for this survey was collected in 2006 at the baseline and in 2008 the end line for 1,126 households. The split up per country is depicted in this table. Turning to the main results. Now the average treatment effect on the treated shows that there's an 80% increase in Kenya and a 23% increase in Tanzania in crop productivity. This means that in Kenya, crop productivity increased from 7,000 to 13,000 shillings per acre. In Tanzania, it increased from 113,000 shillings to 138,000 shillings per acre. Agricultural income also increased. It doubled in Tanzania and it increased by 21% in Kenya. We also observe that women benefited more than men from the farmer field schools. For Uganda, there's no significant impact reported in this study. Subgroup analysis by land size shows that crop productivity increased most for medium-sized land holdings. And also agricultural income increased most for medium-sized land holdings. When it comes to smaller farms, we observe smaller effects that are insignificant. The analysis by education level shows that it is farmers with no formal or with little formal education that benefit most. To conclude, this study shows that farmer field schools have positive effects in the context that was studied. It further showed that female farmers benefited most, which is good news, since standard extension services do not sufficiently target female farmers. The same goes for low-educated farmers. Standard extension services are more beneficial to well-educated farmers. But in this particular context, the farmer field schools show that it is low-educated farmers that benefit most. When it comes to land size, the farmer field schools approach needs some adjustment. We observe that it is the medium-sized farms that have that see the highest effects. But it's actually the smallholder farmers with small farms that are most vulnerable and that can gain most from increases in productivity. This is already the end of this video. If you get interested in farmer field schools, I urge you to pick up the study by Davis and co-authors, and you can also have a look at the 3IE supported systematic review on farmer field schools by Waddington and co-authors. Now this review looked at 500 documents and it comes up with some interesting results. First of all, it shows that farmer field schools are most effective when they are in a pilot phase. Once they go to scale, the positive effects disappear. This could be related to implementation problems. For example, finding and training facilitators becomes more difficult when the scale increases. Another interesting result is that there's no diffusion of knowledge from participant farmers to non-participant farmers. Thank you very much. I hope you found this useful and learned a little bit about impact evaluation of farmer field schools.